Hey everyone, and welcome to The Explainer. Today we're stepping entirely out of the theoretical extremes of economics. We are leaving pure monopolies on one side, perfect competition on the other, and we're wading right into what I like to call the messy middle. This is the actual realm where most of the businesses you interact with every single day operate. We're going to break down exactly how firms behave, how they price their products, and how they react to each other in two very specific market structures: monopolistic competition and oligopoly. It's this incredibly fascinating landscape of strategy, timing, and human behavior. Picture your last trip to the grocery store. You walk down the laundry aisle, and what do you actually see? You've got All, Cheer, Tide, and literally a dozen other brands. Or look at the cigarette market with Marlboro, Winston, Kent. Now you might be wondering, why are there so many options if a detergent basically just washes your clothes? Well, the secret lies in a concept called product differentiation. These products are closely related, sure, but they are not identical in the eyes of you, the consumer. That slight difference, that is the engine driving our very first market structure, and it perfectly sets the stage for our exploration today. So here's our roadmap for making sense of this messy middle. 1. Monopolistic competition defined. 2. Short and long-run equilibrium. 3. The complex oligopoly market. And 4. Cournot and Edgeworth models. Let's get right into it. Section 1. Monopolistic competition defined. Okay. Understanding the rules of engagement here is absolutely critical before we start looking at any graphs or math. Monopolistic competition is basically defined as a market organization where you have many firms selling closely related but not entirely identical commodities. That word many is really the key here. Because of product differentiation, like Tide smelling just slightly different than Cheer, sellers actually have a tiny bit of control over the prices they charge. This means they face a negatively sloped demand curve, which is totally unlike perfect competition. However, and this is the crucial constraint, the existence of so many close substitutes severely limits their so-called monopoly power. If Tide raises its price way too much, you'll just switch and buy Cheer. Because of this, their demand curve is highly elastic. Moving to Section 2, Short and Long-Run Equilibrium. Let's see how time acts as the ultimate tension builder in these markets. What happens today is almost never what happens tomorrow.
There's a massive contrast between the short run and the long run in monopolistic competition. In the short run, a firm can introduce a great new feature, maybe a brand new scent of detergent, and earn some real economic profits. But as we know, success attracts a crowd. In the long run, if firms are earning economic profits, new competitors are inevitably going to enter that industry. This slowly but surely eats away at the original firm's market share, squeezing out all the profit until everyone is merely breaking even. It is a relentless cycle. Now, let's visualize that short-run joy right here. The absolute best level of output for this firm is where their short-run marginal cost curve intersects the marginal revenue curve from below, which is right here at 6 units. If we trace that straight up to the demand curve, the price is $9. But look just below that at the average cost, it's only $7. That $2 gap, that's pure profit per unit, giving the firm a solid $12 in total profit. Life is definitely good in the short run. But let's see how this plays out in the long run. Remember that $12 profit? Well, other entrepreneurs saw it too, and they wanted in. As more firms enter, our typical firm's market share just declines. You can actually see their demand curve shifting down on this bottom graph until it rests perfectly tangent to the long-run average cost curve. Now, the absolute best output is 4 units at $6, but their cost is also exactly $6. The profit isn't entirely squeezed out, and the firm just breaks even. All right, Section 3, the complex oligopoly market. If monopolistic competition is all about the relentless squeeze of time and new entrants, our next market structure is basically an intense psychological chess match. Welcome to oligopoly. This is a market setup where there are only a few sellers of a commodity. And because there are only a few, the actions of every single seller will directly and very noticeably affect the others. Think about it. If one major airline slashes its ticket prices, the other airlines feel it immediately, and they have to react. Because of this massive interdependence, we literally cannot construct a simple, stable demand curve for an oligopolist. We don't know how their rivals will react. Will they match the price cut? Will they just ignore it? Because we don't know, we actually don't have one general theory of oligopoly. Instead, we have to rely on specific behavioral models based on different assumptions. Which brings us to Section 4, Cournot and Edgeworth models. Let's look at one of the most famous of these behavioral models to see how economists try to predict this complex dance. the Corno model. To keep things nice and simple, we're going to assume we have exactly two firms selling identical spring water produced at absolutely zero cost.
So the crucial point here is how this plays out step by step. The basic behavioral assumption Kernot makes is that each firm, when trying to maximize its profit, assumes the other firm will just hold its output perfectly constant. Step 1. Firm A is the only seller. They maximize their profit by selling 600 units. Step 2. Firm B enters the picture. Firm B assumes A is going to keep selling 600. So B looks at the remaining market demand and maximizes its own profit by selling 300 units. Step 3. Firm A sees this happen. Assuming B will stay at 300, A recalculates and changes its output. B then reacts to A's new output. This triggers a completely dizzying series of moves and countermoves. Step 4. Eventually, through all this back and forth, they converge on a stable equilibrium where they both sell exactly 400 units. Let's actually trace this out visually because the logic here is honestly brilliant. Firm A starts as a monopoly, selling 600 units at $6. Firm B enters, looks at the leftover demand, and sets up shop selling 300 units at $3. Now, Firm A reacts to this brand new reality, finding a new demand curve and shifting its position. B then reacts to that shift. If you follow those little arrows bouncing back and forth down the demand line, you'll see the process of convergence happening. They're zeroing in on a single point right in the middle. And this brilliantly illustrates the ultimate conclusion of the Corno model. Just look at that fraction, 1/3. The total perfectly competitive output for this market would be 1,200 units. After all their moves and countermoves at that middle point, Firm A and Firm B will each settle at selling exactly 400 units, which is exactly 1/3 of the perfectly competitive output. They'll both charge $4, making a combined total profit of $1,600. They reach this perfect state of balance despite their constantly flawed assumption that the other guy wasn't going to move. We've covered a tremendous amount of ground in this explainer today, from the profit-squeezing reality of the detergent aisle to the mathematical chess match of those spring water sellers. The messy middle of economics is really where the real world happens. So I'll leave you with this to ponder. The next time you book a flight, or you look at the fierce competition between tech giants releasing new smartphones, ask yourself, which behavioral model are they operating under right now? Are they assuming their rivals will hold prices constant or output constant? The answers might just dictate the exact prices you end up paying tomorrow. Thanks so much for joining me today, and keep looking for the economics happening all around you.